continuation, this is now still part of our lecture for module number 2, which is integral calculus. So this time, diretso tayo sa fourth part of integral formulas, which is in terms of trigonometric functions. Trigonometric functions. So there are several formulas involving trigonometric functions and as well as your basic knowledge when it comes to trigonometric identities. Kung alam nyo pa yung inyong identities from your senior and junior high school, as well from your differential, of course, and introduction to calculus. And later on, after this particular topic, dun tayo sa subtopic involving trigonometric functions, which is now the transformation of trigonometric functions using the four formulas or four types of formulas. Type 1, Type 2, Type 3, and Type 4. But today, we'll just have to introduce trigonometric functions and the first type of transformation. Alam naman na natin that from your differential formulas, the differential of sine u is basically cosine u or cosine of a function. But in terms of integral calculus, we'll just have to inverse the process. So with this, the integral of cosine u or cosine function du is simply equal to sine u plus c. Integral of sine u negative cosine u plus c. Secant squared is simply equal to tangent u. Then cosecant u times cotangent u du is simply equal to negative cosecant u plus c, and so forth and so long. Where this time, if you are now given a function u equal to an angle, you'll just have to differentiate it on its exact differential. Then remember your trigonometric identities, that the sum of sine squared x plus cosine squared x, cosine squared x is simply equal to 1. And 1 plus tangent squared x is simply equal to secant squared x, and so forth and so long. Then some of the identities here are also used with our solution later on under transformation of trigonometric function type 1, 2, 3, and 4, and so forth and so long, up to the last formula involving integral formulas. Now, to make things easier, start na tayo kaagad with our example involving the use of trigonometric functions. Pinakamadali muna nating example is this one. Nababasa naman po kahit papaano yung sulat? Nababasa?
Yes, sir.
Yes, sir.
So with this, you're now asked to evaluate the indefinite integral of cosine 3x dx. Remember that this is also interpreted as cosine u dy. But our function here, u, is simply equal to 3x. And the differential of 3x is simply 3 dx. Knowing that within our integrand, we only have cosine 3x dx. So that we will then now introduce what they call a correcting factor of 1/3 du to our integrand. So that is now 1/3 of cosine 3x dx, such that based from our trigonometric function, the integral of cosine u du is sine u plus c. That is now 1/3 of sine 3x plus c. So as simple as that. Okay, for our first example. So for your next example, number 2, you're now asked to evaluate the indefinite integral of sine of secant 2y times tangent 2y dy. Remember that based from our trigonometric functions, we also have the function of integrating secant u tangent u du is equal to secant u plus c. With this one, parehas lang naman yan, the secant u tangent u du. Hanapin natin yung function natin based in here. U is simply 2y. The differential of 2y is 2 dy. So we'll then need to introduce a correcting factor of 1/2. Correcting factor of 1/2. Then, diretso na ako dito para nababasa. Correcting factor 1/2 integral of secant 2y times tangent 2y dy. Remember that the integral of secant u, tangent u, or the antiderivative of secant u and tangent u is basically secant u, or secant of the function u, plus c. Nag-introduce lang tayo ng correcting factor. 1/2 secant 2y plus c. So, ito na ngayon yung ating final answer for this problem. Yan lang po yan. Bali, umpisa pa lang naman yan, madali. Pero, mamaya, meron tayong mga example that would make you think. Now, number 3. What if you're now asked to evaluate the indefinite integral of tangent squared x dx? Shown in our trigonometric function that there is no an exact integral of a trigonometric function that involves exponents or tangent squared x. Wala siya dito. But, based from our identities, we have those terms as 1 plus tangent squared x equal to secant squared x, which is also the same as secant squared x minus 1. So basically, in this part, we are already performing the method of transformation, but not exactly the formula that involves type 1, type 2, type 3, and type 4 based on the book. But this one, we are just simplifying the problem or expanding our problem using our basic knowledge with trigonometric identities. So we have already know that tangent squared could also be equal to secant squared x minus 1. Then refer to your trigonometric formulas or trigonometric functions. We have that term of secant, or we have the antiderivative of secant squared, which is now equal to tangent u plus c. So basically, with this part of our solution, apply lang natin yung ating properties of indefinite integral. Distribute or introduce our antiderivative or integral sign to each of this function. Secant squared x minus the integral of dx. Secant squared is basically positive tangent x minus x plus c. So, eto na ngayon yung ating final answer. Yun lang. Now, what if you're now asked to evaluate the indefinite integral of tangent 2y minus secant 2y squared dy? Wala tayong identities that involves the difference of tangent and secant. Wala dito, di ba? Hindi natin makikita. Pwede naman, no, that is squared. Wala. So, wala. So, basically, ang pinaka other option natin with this particular problem is to expand the term using expansion of terms. So, tangent 2y raised to 2 is simply tangent squared to y minus 2 tangent to y times secant to y plus secant squared to y, then dy. Then, very basic thing for us to do in this particular part of our solution is to distribute our antiderivative, or your integral sign. That is tangent squared 2y dy minus 2 of tangent 2y secant 2y dy plus the integral of secant squared 2y dy. Okay? Nasusundan yan? Then, we also know na ngayon, with this part of our solution, meron na tayong nakikitang similarities or use ng ating trigonometric identities. We have tangent squared to y, which we can also express that as secant squared to y minus 1 dy minus 2 secant to y tangent to y dy based from our trigonometric function. Diba? Merong integral yung form na yan. That is that. So, hindi na natin gagalawin. And, meron ding integral si secant squared to y. Isa-isahin natin ha. Ito munang first part. This is integral of secant squared to y dy minus the integral of dy. That is now what? The integral of secant squared is tangent u. Or meron tayong term na 2y doon sa loob. So basically, mag-i-introduce tayo ng Introduce tayo ng correcting factor na equal to ilan? Magsao kayo.
1/2, sir.
1/2. Then integrate secant squared, which is now tangent to y. Then integral of dy is simply y. Diretso tayo dito. The integral of secant u times tangent u is simply equal to secant u. Knowing na meron tayong term na 2y doon sa ating integrand, again, we'll have to introduce a correcting factor of what? 1/2. So 1/2 times our constant 2 is basically 1. Then the integral of secant 2y tangent 2y is basically secant 2y. Minus again the integral of secant squared 2y dy, which is the same as 1/2 tangent 2y plus c. Simplify further. 1/2 tangent 2y minus 1/2 tangent 2y. Ay, bakit minus? Plus pala yun. 1/2 tangent 2y plus 1/2 tangent 2y is simply tan 2y minus y minus secant 2y plus c. This will be now our final answer. Question po. Hello?
Answer.
Hello?
Answer.
Yan, burahin ko lang ha. Example number 5. What if you're now asked to evaluate the indefinite integral of sine x dx over cosine squared x dx. Ayan. Cosine squared x dx. Bakit ganun? Cosine squared x. We can also simplify that as sine x of cosine negative 2x dx, di ba? Parehas lang naman. Then we know that the differential of cosine x is simply equal to negative sine x dx, which will lead us to introducing a correcting factor of negative 1 over 1. Meron tayong sine x dx dito sa ating term or sa ating integrand. So basically, matatanggal lang yung sine x, then magiging negative 1 times negative sine x of cosine negative 2x dx. So cancel yan. Simplify, that is now negative cosine raised to negative 1 times x. Gagamit na tayo ng power formula at this point. Kasi the differential of cosine negative 2x, negative 2 raised to negative 2x is simply equal to sine x. So never mind that. Then power formula, negative 2 plus 1 all over negative 2 plus 1, which is now negative 1, and plus c. Simplify, that is now 1 over cosine x plus c. Ito na ngayon yung ating final answer. Number 6. What if you're asked to evaluate the indefinite integral of cosine squared x dx over sine x? We know from our identities, our basic knowledge with identities, that cosine squared x is also 1 minus sine squared x dx. So, ganyan lang din naman siya. Such that, distributing our antiderivative, this is now dx over sine x minus sine squared x over sine x dx. This is now what? A function that carries a negative exponent, an exponent raised to negative 1. So, apply na din si logarithm. So, this is now ln of sine x minus, cancel, mayroong isa. So, integral of sine x dx. This is now negative, positive cosine x. So, minus cosine x plus c. So, yan na yung ating final answer for that problem. Number 7. You're now asked to evaluate the indefinite integral of cotangent squared y dy. From our trigonometric identities, we know that cotangent squared y can also be expressed as cosecant squared y minus 1 dy. Distributing the antiderivative, cosecant squared y dy minus the integral of dy. Simplify, the integral of cosecant squared u. Ano yung integral ng ating cosecant squared u? That is negative cotangent. Negative cotangent y minus y plus c. Ito na naman yung ating final answer. Number 8. What if you're asked to evaluate the indefinite integral of 1 plus cotangent 2 theta squared d theta? Yun na. Wala tayong equivalent trigonometric identities that involves the sum of 1 plus cotangent x. Diba? So, kung wala sa identities, anong gagawin natin with this particular integrand? So, basically, we'll just have to expand the term. So, 1 plus 2 cotangent 2 theta plus cotangent squared 2 theta d theta. Ngayon, introduce natin yung ating antiderivative or integral sign. Baka mamaya may makita tayong similarities with our trigonometric identities. That is d theta plus 2 integral of cotangent 2 theta d theta plus the integral of cotangent squared 2 theta d theta. So with this one, basic power formula, that is only theta, then apply your our formulas involving trigonometric functions. Okay? That is theta 2 integral of cotangent theta. Check natin dito. Integral of cotangent is simply ln sine u. But we have a term 2 theta here. So, kailangan nating mag-introduce or the differential of 2 theta is basically 2d theta. Then, we'll have to introduce a correcting factor of 1/2. So, sa correcting factor, 1/2, isa-isahin ko na lang, 2, correcting factor 1/2, integral of cotangent is ln sine u, or meron tayong 2 theta, so 2 theta, plus the integral of cotangent squared u. Meron ba tayo nun? Na integral of cotangent squared u. Wala tayong integral ng cotangent squared to theta. Meron ba? Wala. But we can express cotangent as using your trigonometric identities, 1 plus cotangent squared x equal to cosecant squared. So we can express that as cosecant squared 2 theta minus 1 d theta. Diba? Solve na natin yan kanina. That is also equal to cosecant squared 2 theta d theta minus the integral of d theta. Now, the integral of cosecant 2 theta or the cosecant squared is simply negative cotangent. Or, introduce natin yung ating correcting factor 1/2, then negative cotangent theta. Negative cotangent 2 theta minus theta. Or simply, that is now what? Negative 1/2 cotangent 2 theta minus theta plus c. Simplify, theta minus theta cancel. That is 2 times 1/2 is 1. Then ln sine 2 theta minus 1/2 of cotangent 2 theta plus c. Tama ba? Cosecant is negative. So, tama. Nag-introduce na naman. Okay. Yun lang po yan. Question. Hello? Hello?
Paano pong malalaman na